This lesson is on section 21.3, which is on combinations, and we're going to start the lesson with a couple exploratory problems so you can hopefully understand the difference between permutations, which we did in the last section, and then combinations, which is the new section. So for problem number 1, how many ways can 3 people be elected from a group of 5 people to serve as president, vice president, and secretary? And so go ahead and try that one, and then after you have done that one, then explore this problem number 2. This time we just want a 3-person committee. So we still have 5 people that are available, and then we're choosing 3 people for the committee, but not for specific jobs like president, vice president, and secretary. We're just looking for a 3-person group. So you can explore that and see how many different groups you can come up with. So pause your video, try those 2, and then press play when you're ready to check your answers. So we can approach number 1 a few different ways. There are 5 people available for the president spot. And then once we picked one for there are only 4 people available for the vice president spot, and then 3 people left for the secretary spot. So if we multiply those, we get 60. Another way to get that is to realize that this is a permutation. We're just seeing how many ways we can permute 3 people out of from the 5 original people, and so that is 5p3, which is also 60. Okay, now problem number 2 is asking something different. It's just saying how many groups of 3 people can we pick from the 5 original people. So if my people are named A, B, C, D, E, A, B, C in any order, that's one group. Okay, so there's one. I could do A, B, D. That's another group. I could do A, B, E. That's another group. And then I could also do A, C, D. I could do A, C, E. And I think those are all the groups that have person A in them. Okay, and then so A is no longer part of the picture. So now if we look at B, we can do B, C, D as a group. B, C, E as a group. Okay, and then let's see, I think that's it for starting with B. And then there's only one group left. C, D, E. Let's see. Oh, I think I missed one I did. These 2 had B and C, but I didn't do, if we exclude C, we could also have B, D, E would be another one. So I'm still missing one because there are 10 altogether. Let's see. What I'm missing is A, D, and E. A, D, E. And so those are the 5 different or 10 different groups of people that we can get when we have when we're just looking for a committee, and the order doesn't matter. We're not assigning them to specific jobs. We just have these 10 different 3-person groups. Okay, and so this is a problem number 2 demonstrates what a combination is as opposed to a permutation. So we said there are 60 different permutations. That's where the order matters. But this is an example of a combination where the order doesn't matter. Okay, so for permutations, the order matters. So when we change the order, that changes the permutation. And then for combinations, the order doesn't matter. Picking 3 people doesn't matter what order we pick them in. Okay, and then as far as the equation, you learned in the last section that n items permuted r at a time. The formula for that is n factorial over n minus r factorial. For combinations, it's the same as permutations, except that every time we pick a group, we want to see how many different ways can we arrange those and divide those possibilities out. And so for this one, we originally had 60. We had, let's see, it was 5 factorial over 2 factorial. But then we have to divide by 3 factorial because every group of 3 has 3 factorial ways of permuting them. So we're going to divide by r factorial also. And so for this one, that would be 5 factorial, 2 factorial, 3 factorial. And you see that that does come out to 10. This is 120 over 2 times 6. So that shows that it is 10. So the number of combinations, the notation is NCR instead of NPR. And that is always n factorial over n minus r factorial r factorial. And you can also find that in the same place on your calculator under math probability. Right under NPR is NCR. Okay, so we could do 5 math probability NCR 3, and that is 10. Okay, so that's what we're going to focus on today is combinations, or being able to tell the difference between permutations and combinations. So if you have your book, we're gonna use that for the notes for today. So go ahead and open your book to page 1108. And on 1108, you see the formula that we just talked about for combinations. And the C stands for combinations, but it makes sense in most of the problems that we do if instead of saying combination, you just say choose. So when we write NCR, we're going to say N choose R. And you'll see in this next example or the previous one that we did that the term choose actually makes sense. On that previous example that we did, we had 5 people and we were choosing 3 people to be on the committee. And so 5 choose 3 instead of saying 5 combination 3, which doesn't really make sense to us intuitively. But if we say choose, we have 5 people and we're choosing which 3 get to be on the committee. So for this example, we have 4 boys and 8 girls. The coach randomly chooses, so you see the word choose is already there. That's a good indication that it's a combination. So the coach randomly chooses 3 of the students to participate in the competition. What is the probability that the coach chooses all girls? And so we use that word choose twice there. And so the number of items in the sample space, we have 12 people, meaning 4 boys and 8 girls. So we have 12 people, and we're choosing 3 of them to go to the competition. So that's 12 choose 3, or 12 factorial over 3 factorial, 9 factorial, and that is 220. Event A is that he chooses all girls. So there are 8 girls, so it's going to be 8 choose 3, and 8 choose 3 is 56. So then the probability is 56 divided by 220, which is 14 over 55, which is also about 25.5%. The next one, on the next page, we have a 52 card deck, which is a normal deck of cards. 5 cards are randomly drawn from the deck. What is the probability that all 5 are diamonds? And so we have 52 cards. We're going to choose 5 of them. And so that's 52 factorial over 5 factorial, 47 factorial. Or you can just use your calculator and do 52 choose 5. 52 choose 5 is about 2,598,960. 598,960. Okay, and then event A is combinations of 5 cards drawn from there are 13 diamonds in every deck. There's 13 diamonds, 13 hearts, 13 clubs, and 13 spades. And so we have 13 diamonds. We want to see how many ways there are to choose 5 of them. So that's going to be 13 factorial over 5 factorial, 8 factorial. So 13 choose 5 is 1287. The probability of randomly selecting 5 cards that are diamonds is 1287 over 2,598,960. Is equal to 33 over 66,640, or about 0.0005, which if you move the decimal place 2 places is 0.05%. Okay, for number 4, if we toss a coin 4 times, then the sample space, the total number of possible outcomes, each coin can have 2 possible outcomes because it can be heads or tails. So heads or tails, heads or tails, heads or tails, heads or tails. So that means there are 16 possible outcomes. So that means the number of items in our sample space is 16. And what is the probability of getting exactly 3 heads? So 3 heads could look like this. Heads, 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 tails, or it could be heads, heads, tails, heads, or it could be heads, tails, heads, heads, or it could be tails, heads, heads, heads. And so we can easily count that there are 4 of those outcomes, but in the future, just so we don't have to list them all, this is 4 choose 3. We have 4 spaces and we're choosing which 3 of them need to be heads. And that answer, if you do the combination formula, that's 4 factorial over 3 factorial, 1 factorial, which just turns out to be 4. It also makes sense to say that this is 4 choose 1, because 4 choose 1, what we're doing is we have 4 spaces and we're choosing which one is going to be a T. And so 4 choose 3, you're choosing 3 spaces to be heads, or 4 choose 1, you're choosing 1 space to be tails. It turns out to be the same answer, which is also 4. And so that means the number of ways that event A occurs is 4, And so the probability of event A occurring is the number of ways that event A occurs over the number of items in the sample space. So that's 4 over 16, or 1/4. Okay, now go ahead and pause your video and try number 5. Press play when you're ready to compare your solution to mine. Okay, so we are dealing with 26 cards because we have 13 diamonds and 13 hearts. Those are all the red cards in the deck. And so the number of items in the sample space is 26 choose 4. We're choosing 4 cards from the deck of 26 cards. So 26 choose 4 is our total number of outcomes. And so if you do that on your calculator, 26 math probability NCR 4. So 26 choose 4 is 14,950. And then the number of ways that we choose all diamonds. So event A is that we get all diamonds. So the number of items in event A, there are 13 diamonds. We're going to choose all 4 of them. And so if you take that previous one on your calculator and just change that to 13, now it says 13 choose 4, and 13 choose 4 is 715. And so the probability of all diamonds is 715 over 14,950. So 715 divided by 14,950 is that decimal, so about 5% or 4.8%. And we can also go math frac and see if we can simplify that any. So that simplifies to 11 over 230, or about 4.8%. Okay, now let's skip to page 1111, and I'll go through number 6 with you. So this time we're looking at a test that's all true-false. A new test is created by selecting 6 questions, and so the total number of possible outcomes, each question can be true or false. So 1, 2, 3, 4, 5, 6. 2 possible outcomes for that problem, 2 possible answers for that one, 2, 2, 2, 2. So that's 2 to the 6th power, or 64. And then it says, what is the probability the new test contains at most 2 questions where the correct answer is true? So at most 2 questions means 2 or less. Okay, so that means it could be, so our number of items in our event A is the number of ways that we get 0 true, plus the number of ways that we get 1 true, plus the number of ways that we get 2 true. Okay, and so 0 true, that means they're all false, so there's only one way that that happens. 1 true, that could look like this. It could look like false, true, false, 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 false. So out of the, there's only 6 questions, 1, 2, 3, 4, 5, 6. So out of the 6 questions, we're choosing which one is going to be true, and so that is 6 choose 1. We're 6 questions, choose which one is true. Or you could do 6 choose 5. The answer is going to turn out the same because you could be choosing which 5 of them are going to be false. Choosing 2 true, so that would be 6 choose 2. For the same reason, we could have true, false, false, false. And so out of the 6 spaces, we're choosing which 2 are going to be the T's. Or you could do 6 choose 4, and that would be choosing which 4 are going to be false, and that'll give you the same answer also. And so 6 choose, so we have 1 plus 6 choose 1 is 6, and 6 choose 2 is 15, and so that turns out to be 22. And so then our probability of getting at most 2 true is 22 over 64, or 11 over 32, or about 34.4%. Okay, now I would like you to try number 7. So go ahead and pause your video, try number 7, and press play when you're ready to compare your solution. Okay, so for number 7, we're picking 5 people, and each person could be a male or a female. So there are 2 options for the gender of each one, and so that is our number of items in our sample space is 32. And then we want to know what is the probability that the council will contain at least 3 girls. So the number of ways that event A occurs is the number of ways of getting, so at least 3 means 3 or more. So it could be 3 girls, 4 girls, 5 girls, or all 6 girls. Oh no, we're only picking 5, so that's it. So 3, 4, or 5. And so this is going to be, so that would be like this. That would be girl, girl, boy, girl, boy. Okay, so out of the 5 spaces, we're choosing which 3 are going to be the G's. And so that is 5 choose 3. And then for 4 girls, that would be 5 choose 4. And for 5 girls, that would be 5 choose 5, which is just 1. This is 5. And 5 choose 3 is 5 choose 3 is 10. So we get 10 plus 5 plus 1, which is 16. And so then our probability that event A occurs is 16 over 32, which is 1/2. And that completes today's lesson. Email me or stop in on my office hours if you need help. Have a great day.